working with stacks though, sorry, structs. Working with structs, it kind of like, it gives me the impression that like that's how I would switch between different types of characters I could. Like, if I were to have an assassin character, and then a hacker character, and then a tagger character.
That's very important. We'll go over that as well. Let's do a really simple example. The purpose of the code I'm going to write is, let's say I just want to grab the area of a rectangle. Now, if we didn't use struct, we didn't use for loops, it'd be really easy to do, let's say, one rectangle. You might have int, or I'll do float. I want decimal points for my width and height for my rectangle. Right? If I want a rectangle 3.5 units wide, I can have 0.5. I want my decimal. Width, float height. And that's all that's needed to define a rectangle, width and height. The opposite sides are always of equivalent length, equal length. Here when you say equal or equivalent, we're not in the geometry class. Anyway, we've got width and height. And let's say I want to print out the area of this rectangle. So let me include my I/O string using namespace. All right. So here is where I want to print out the area. And I'll just freeze the input. All right. So I only have two variables. I have width. I have height.
Decimals.
Currently, tell me about these variables. What does this line right here do? What does line 10 do?
It tells us the decimal of the width, but it's not the width isn't assigned yet.
There's a single statement in this line. And what does that statement do? What's the code doing in that line? Telling you the width will be don't talk to me like I'm a person. Talk to me like I'm a computer. What is happening? A variable is being declared.
Okay.
Even though it's got this name width, is it used anywhere yet? No. Is it storing the width of anything? No. When we program, we usually come up with some abstract concepts. But until they get used, until I implement this to do something related to width, it's not doing anything. So when you're looking at code, don't assume that just this name means something. Don't assume it's doing that. Currently, it takes no value. So this could be flavity goose, whatever. And then I ask you, what's happening in that line? And what would you say?
But is it already setting memory aside based on the data type?
From what I just did is I changed the name of the variable. Has anything changed?
I mean,
no. Until I use it, it's not doing anything. When I declare the variable, yes, the computer will set aside memory for it. But in terms of what this program is doing, it's not doing anything.
So what happens if you don't declare it? Like, if you just left it like that, how much memory would it? Make the code ineffective. But like, if you accidentally initialized something, and you never give it a value, and it's just sitting there in your code, like, is that taking a lot of memory, or is it really making it bad? Or?
It's on the data type. Different data types take up different amounts of memory. A Boolean takes up the least amount of memory, since it can only store true or false. Since a float can handle decimal points, it takes up more memory than for say a short int would take up less memory than a float. A double would take up twice as much memory as a float. Anyway, so I just named this variable something dumb to illustrate that the name means nothing. What's in a name? It doesn't matter what you name it. Now, as good programmers, as good engineers, we try to name things, we try to give it a name that represents what we want it to do. But until I write the code to do something with it, it's just a name. All right, so this is what kind of statement was line 10? What's happening?
Declaration.
What is this? What does this word mean?
Float.
Why is float in blue? It's a data type.
Data type.
If a word's showing up in blue, that means it's a reserved word. It's a word reserved for the language itself, reserved for C++. And float is a reserved word because float is a data type. I couldn't have a float named float. I can't do that. It's reserving the word float for the data type. I couldn't have an int named float. It would be equally confused. In line 10, this statement is a variable declaration because it's a data type name. It creates a named variable. That's it. All it's happening in line 11 as well. So if I wanted to give values to these, now tell me what the statement in line 10 does. It does more than one thing now, doesn't it? What did it do before? Guys, what did line 10 do before I made those changes?
It only declared the width.
It declares a variable. Of what type?
Float.
Float. And of what name? This is variable declaration. It's still declaring a variable. It still says float width. That's still happening. This is still a variable declaration. But what else did I do here?
Give it an initial value.
I gave it an initial value. What's that called? Initialization. Giving an initial value is called initialization. So now I am declaring and initializing a variable called width. Let's do the same for height. So I have two variables. They're named variables. They're both floats. And they have an initial value. Where do I need to add to this code? You just have to make a guess. Look at what I've named my variables, what I've said I want to print out. Could you infer what the rest of this code should be?
We're going to find out what the area is using those variables.
That's a very good idea. What clued you in? So right now it's going to print out the area is blank. So right here, if I put the area, right in here is where I want the area to exist. It'll say the area is, and then it will print out that value. How can I calculate the area based on the variables I currently have?
Multiply them.
I can multiply them, because area is height times width. Width times height. Whichever way you want to slice it. So I'll make a guess. What's it going to print out when I run this program? Not just 9, it's going to say the area is 9. So I also said print out this. And there's my output. The area is 9. We can also say the area for this rectangle is 9, and its width is 3, and its height is 3, and it lives at 0, 0, and it's got a best friend named Susan. We can go on. So I have two variables, and they're keeping track of a rectangle. Now, based on this code, what actually says this is a rectangle? Nothing. There's nowhere in my code where I'm saying I have a rectangle. Right? I have two variables, width and height. We're inferring, we're assuming there's a rectangle involved. That was what I said I wanted to do. But I don't have a variable for that rectangle. I have two variables representing the abstract concept of a rectangle. Wouldn't it be great if we could group these variables together? And that's why we use struct. I'm going to make a struct, and a struct is just grouped variables. It's a new data type made up of multiple variables. We'll take some space, and I'll write struct. Rectangle. Open bracket. Close bracket. Semicolon.
Data type declaration.
Rectangle. And anything I type between those brackets, any variables I declare between these brackets, will all be owned
by rectangle.
Rectangle is the name of the group, and every group should have some members. So what did I say it takes to define a rectangle? What should I put in here? a width and a height. Float width, float height. I'm going to remove, I'll leave it for now. So we're going to struct rectangle, float width, float height. What is the scope of those variables? Where do these variables exist? Within the struct. Within a struct named rectangle. The scope of these variables. When I say scope, it's just who owns them? Where do they belong?
Scope is ownership.
Just what are the closest curly braces? These guys only exist inside of rectangle. Now I'm going to modify some of this code. Since I now have a struct that groups together these two variables, I don't need width and height anymore. I don't need them here. I can just declare a rectangle. Rectangle, box 1. Now, if you've typed this so far, and I'll comment out my output line, because currently these two variables don't exist. Right? These are going to give me errors. It's going to say height and width got deleted. I don't know what you are. Let me just comment them out for a bit. So I made, what is line 16? What kind of statement is line 16? What type of statement? It is a type of data type. It's a call. Line 16 is a variable declaration because there's a data type and a name. All this is doing is saying, hey, build me a rectangle. Call it box 1.
So as long as it's in that bracket, could you put another rectangle in that bracket with a different name, or do you have to put a different bracket?
You had a question.
Yeah, it's a data type that it's not in blue.
It's not in blue because this is a data type we have defined ourselves. It'll show up in blue if it's a reserved word of the language, but we could rename our data type. This is something we've created, so it will not show up in blue. In some IDEs, in some environment software, it will color your own code, which is nice. Currently, Visual Studio is not doing that for us.
This is what you need.
Joseph, what were you saying?
Now, if you put another rectangle in box 2 in the same curly brackets, it'll make it.
Main function?
Yes. It doesn't have to be in different brackets.
Done.
Huh.
I have two rectangles. One's called box 1, one's called box 2.
Huh.
Up here, this is where I'm defining what that data type is, and here's where I am using that data type. This is the blueprint. This is it actually being built.
Huh.
Now let's talk about the period, the dot. I see box 1. What data type is box 1?
Rectangle.
It's a rectangle. What does a rectangle do? What is it? Tell me what rectangles are like. The definition's on the screen. There's not a lot to it.
Height and a width. But
A struct rectangle contains numbers called height and width. If I want to access my rectangle, the only things I can really modify about a rectangle are these. So if I want to access them, I say the name of the rectangle, I type a dot, and we'll look at what it already is trying to autocorrect. I know it's kind of tiny. If you're writing on your screen, though, when you press dot, you see the same option. It says, hey, I found a height and a width. I found variables that rectangle is in control of. Box 1 dot height equals 3. Box 1 dot width equals 3. It's saying, look, I found a height and a width variable, but they all belong to box 1. What if I want to set the height and width of box 2? What should I type?
Box 2, that height equals. Wait, does that make it a square?
so the dot makes the scope of. So the dot assigns the scope of.
Yes. That lets you access numbers owned by other things. When we call cn.ignore, that's because somewhere there's a definition for cn. And one of the things it owns is a function, since there are parentheses, a function called ignore. When you have these absolute values for the homework, that was a function call. We didn't have to type dot though, because it's such a basic function call. C++ included its class for us. But for things that we just created, when we want to access its parts, type dot. Now how would I modify line 23 with my new information? Let's say I want the area of box 1. What should I type here?
Box 1 that I can start in that way.
That's it. The area is 9. Alright. Now that code was just for 2 boxes. What if I want 3 boxes? Or 4 boxes? Or 5 boxes? Or 6 boxes? Do you want to go on with this? What if we need a large number of boxes?
Just make more boxes with rectangle data type.
I can keep doing this. I have to number them all different. That's going to get a bit of a pain. That's a lot of work. Why should I have to type all this out when I can make the computer do that for me? I can make an array. I can make a list. And it's going to create as many boxes as I want. So this time, instead of saying rectangle box 1, which I'll leave there, just so we remember what that syntax looks like, I can say rectangle, asterisk, boxes. There's now an array of boxes, an array of rectangles. Boxes equals new rectangle 100. So boxes with point to rectangle is going to have an array, a list of 100 rectangles. We need to know what the asterisk means. Let's talk about that again. Why do I have to type an asterisk? What does that mean?
Multiplication?
It is sometimes used for multiplication, but that's only when it is used between 2 variables, between 2 constants or numbers.
So like arrays are good for item lists and probably computer-generated bots and stuff?
I'm not talking about arrays quite yet. Just why did I have to type an asterisk? What does it represent here? And this is something I think I've covered many times. I'll say it again.
Doesn't that point to something?
It's called a pointer, correct. Most types of variables we've worked with, most data types, we've, like what I call int x. The computer says, I see you want to store an int somewhere. Let me allocate memory. And it does this as soon as the program runs. It does it at program startup. When the program starts, it makes a list. It looks at every variable it needs to run, reserves that much memory, and then it runs. And your memory needs do not change at runtime. Do not change while the program's running. A pointer means instead of storing this rectangle, instead of just storing a rectangle, store the address. The address of the memory for that rectangle. When int x is declared and the program reserves memory for int x, it has to pick some place of memory, and every bit of memory on a computer has an address. The computer does all this work for us normally. It says, I've kept track of all of your open slots of memory. They all have addresses. And I've said, reserve these three bits to store something. Reserve these 8 bits to store an int. And when we want to access it, we can just type the variable name. So the computer says, aha, I know where to find this because I stored this address. A pointer, which is declared by having an asterisk, means that instead of storing just the memory, we want this variable to store the address of itself. This is important for an array. This means that we can change the size of an array at runtime. While the program is running, when it gets to line 18 at startup, it says, oh look, I need to store enough space for a single rectangle. It only knows that there's going to be one rectangle. It's going to store it here. But we need to keep track of the address. Because when we call line 19 and we say, make a new array of list size 100, it says I need to reserve 100 spaces. and I'll reserve the 100 spaces following that first address. I'll make them all neighbors. It's okay if this is a lot of abstract computer knowledge. But when we call rectangle, when we want to access one of the boxes, right, I can say which box to get. And I have up to 100 choices. It's going to say, box number 5. Well, let me go to the first box and count up. 1, 2, 3, 4, 5. I found it. Now, if I did this, if I just said rectangle boxes 100, that would run. But I could never change this size. I could never change the size of the list. By making it a pointer, I can instead of just say make a list 100, I can make a new variable. I could use that int x, and I could get user input. And the input could decide how many boxes to make. And every time it runs, the user can type in a different number. So the program at startup never knows how long that array is going to be. That's the power of pointers. For now, just be familiar, this is how I want you guys to declare arrays. Hopefully that explanation made some sense. But we have a lot of other things to go over today, so we'll move on for now. Just know that I can make this list be any size I want. Okay. So we still have a box 1. I never deleted it. I left them around. I'll get rid of int x. Keep that first rectangle. Boxes is now the first in line for 100 other rectangles. And again, I can have the user set this. We can change this number anytime we want. So then rather of me having to set the individual values for 100 boxes, instead of me saying box 1 dot x, box 2, or dot height, I guess I should say. Right, if I wanted 100 boxes and I didn't make an array, I'd have to manually type in 100 times. That would be pretty tedious and annoying and terrible. No one would have fun. So here's what I'll do. Since I can access all 100 boxes just by typing in which number box I want, I can do a for loop that will run through every single box in the list. When you declare a for loop, you need 3 things. You need what variable is in charge, you need the condition for it to stop counting, and in what way to count. You can make a for loop count up, you can make a for loop count down, you can make a for loop do every other number. I just want to count up. I just want to run through all 100 boxes. So int I equals 0. I'm going to start counting at 0. While I is less than 100, since that's how many boxes I have, and I want it to count by 1. So I plus plus. And I can say boxes of I dot width 3 boxes of I dot height equals 3. So instead of me having to write this 100 times, I can write it once and just run it 100 times. Just like a while loop, a for loop loops the code inside of it. Now to make this a little more efficient, instead of writing 100 2 times, I'm going to make a variable for how many boxes. I'll call it int box count. Set to 100. That way, if I ever change how many boxes I want, instead of having to change the number here and here, I can just change the starting value of box count. Do that. We'll get rid of box 1 finally. So, I created a structure which just groups variables together. I then made an array of that structure. I made an array of rectangles or boxes. I stored how many I want to make. And I said, make this pointer of boxes point to a big old list that's 100 long. This for loop is going to count from 0 all the way up to box count. And every time it counts, it's going to set the box at location I to have the width of 3 and the height of 3. How many times will this go execute?
100.
100. How did you know that?
Because it was set to 100.
So it counts from 0 up into box count. The box count is 100. So anything in here is going to execute 100 times.